So we had completed this problem, right? Means just we had completed this problem up to g parameter. We did it, h parameter, t parameter. Now what we need to do, in this problem the question was we have to solve, the question was we have to find the t parameter also. So for finding the t parameter, you you need also, means let me select the, okay, let me select the network. So we discuss this problem, okay. So, mm, yeah, so we are doing this problem. So Prasanna, what is the equation for t parameter? Can you tell me what was the equation for a t parameter?
V1 equal to AV2 minus BI2.
Wait, what are you telling? V1 is equals to
AV2 minus BI2.
AV2 minus BI2. And what is the equation? And another equation, second equation?
CV2 minus BI2. I1
CV
equal to
I1 is equals to CV2
minus DI2.
minus DI2. So this is the equation. Okay. So the value of A can be what? I2 by V1 by V2 while making I2 is equals to 0. Okay. So this is very simple. This is the transmission line parameter. You need to find the value of A is equals to, and by equation, by seeing these equations only, we are getting the value of A is what? V1 by V2 when I2 is equals to 0. If you will make the I2 is equals to 0, if you will make the I2 is equals to 0, this is I1 and this current is I1. Okay. So if you will make I2 is equals to, this is I1, sorry, this is I1. So what will happen? And we need to find the value for V1 by V2. So suppose this is X. Okay. Do the KVL. So what you will get? And what was the ohm? Means this branch register 2 ohm. Yeah, 2 ohm register in this branch. So if you are making I2 is equals to 0, you are getting the 0 volt here. Minus V2 plus 0 into 2 minus 4I1 plus X is equals to 0. So what I am saying, what you are getting, one equations you are getting, or we can say you are getting the value of X is equals to 4I1 plus V2. Okay. So you got the value of this. This is this is this is I1 current. So these I1 current directly it will come, because this I2 current is 0. So another equations you are getting minus V1 plus 3I1 plus X is equals to 0, and V1 value is X plus 3I1. You know the value of X, you can substitute it, 4I1 plus V2, 4I1 plus V2 plus 3I1. So what you will get? V1 value, what you will get? V1 value 4 plus 3, 7I1 plus V2. Can anyone tell me what will the value of I1? I1 value we can also write X minus 0 upon 10, because this is the same current now. This is the same current, because this current is 0 and this is the potential. So if you will substitute the value of X, what is the value of X? x is equals to 4i1 plus v2 divided by 10. It is equals to i1 only. So 4i1 plus v2 is equals to 10i1. So what you are getting, v1 is equals to 6i1 and i1 is equals to v1 upon 6. Substitute here. v1 is equals to 7. Instead of i1, what you will get, v1 upon 6 plus v2. Solve this equation. What you will get, you will get to know v1 minus 7v1 by 6 is equals to v2. Okay, so minus v1 by 6 is equals to v2. So what you are getting, you need to find the value of v1 by v2. So v1 by v2 is coming minus 6. This part is clear? This part is clear, everyone? Anish, it's clear?
Yes, sir.
Okay, Anish. So if you are getting the value of a is you got the value of a is equals to minus 6. Okay, what about the value of a b? In the same way, you need to find the value of a b. In the same way, you need to find the value of a b. So value of a b means what? Value of a b. B means b is nothing but b is minus v1 upon i2 while making v2 is equals to 0. Am I correct? Minus v1
Yes,
upon
sir.
i2 while making v2 is equals to 0. If you will do this, that means your v2 is 0. You are doing the now the thing is changed. This is not 0. The i2 is not 0.
Sir?
Yeah.
Sir,
Yes.
I1 value equal to V2.
I1 value is hello. Your voice is not coming, Priyanka. Priyanka, your voice is not coming.
V2 by 6, sir.
Oh, I1 value is V2 by 6. Okay. Okay. That is that you are saying, then it's a correct only. So I did some mistake here. So okay, very nice. Means we had seen this. So just substitute this, what you are getting in this equation, you will get the value of a. Okay. So if this is V2, I committed mistake here. So V2 is equals to I1 is equals to V2 by 6. V2 by 6. So I1 is equals to V2 by 6. So what you will get? Just solve it and say, Priyanka, what you will get? V2 by 6. So V1 is equals to 13. That is V2. So V1 will get 13 V2 upon 6. So V1 by V2, we are getting 13 by 6. Okay, nice Priyanka. You had seen this small mistake. So B is equals to minus V1 by I2 and V2 is equals to 0. Okay. So this part we are getting B is equals to minus V1 by I2 and V2 is equals to 0. So how to solve this? We are just shorting this circuit. V2 is 0 means what? We are just shorting this circuit. And we need to find the ratio between V1 and I2. V1 and I2. This is your I2 current. Okay. So how can we do it? Apply the KVL and get the result. So we have this equation. So minus V1 plus 3I1 and this is X. This you can take it as a X, or you can take like this also. I1 current is coming and I2 current is coming. So you can take it as a I1 plus I2 into 10 is equals to 0. So V1 value, what you will get? V1 is equals to 4i1 that is 13. This is multiplied by 10. So 10 plus 3, 13i1 minus 10i2. So these equation we are getting, and we need to find the ratio of a v1 upon i2. So the i1 value we need to know what will be the value of a i1. Okay, for this substitute, for this solve one KVL in this equation. If you solve one KVL in this equation, so now your v2 value is 0. So minus 0 plus 2i2 minus 4i1 plus 10 into, you know, the current i1 plus i2 is coming is equals to 0. So what we are getting, 2i2 minus 4i1 plus 10i1 plus 10.
Sir,
Yeah,
sir,
yes.
V1 value
v1 value where?
less than I2.
Okay, so see it's a 0 na, it's equals to 0 na. So v1 is equals to, if it will go that side, it will become, see this part, if you are seeing, if this will go that side, so it will become 13. Yeah, it's correct, only 10i2. So 2i2 minus 4i1 plus 10i1 plus 10i2 is equals to 0. So what we are doing, 2i2, solve this and get the result. So it is coming as a 6i1 plus 10i2 is equals to 0. So what we are getting, 2i2 plus 16, 2i2, this is i2 na, so 12i2 plus 6i1 is equals to 0. So what is the relation between i1 and i2? i1 and i2 relation, what we will get, 6i1 minus 12i2. So this will get cancelled out. So i1 is nothing but i1 is minus 2i2. Substitute this in this, the value of i1 in this. So you will get minus 13 into 2, 26, minus 26 i2 plus 10 i2. So v1 is minus 16 i2. So we need to find the value of v1 by i2. So v1 by i2 is equals to minus 6. Transfer this minus this side, so minus v1 upon i2, we are getting 16. So you know the value of a b value is coming, how much it is coming, 16. So in the same way we need to find the value of a c. So in the same way we need to find the value of a c. So what is c? C is i1 upon v2 while making i2 is equals to 0. Okay, so form the equation. Now your i2 is 0. So your i2 is 0, but your v2 is not 0, and you need to find the value of the ratio between i1 by v2. So first form one equation from this side. Now your v2 is not 0, so this is not at all 0. So what you will get, what the things you will get, this is i2, and so form the another equations, minus v2 plus 2i2 minus 4i1 plus this branch current is how much, i1 plus i2, so plus 10 i1 plus i2 is equals to 0. But your i2 is 0, so it's 0. So what you are getting from here, this i2 is 0, so it's 0 only. So what you are getting from here, v2 is equals to 6i1, right? v2 is equals to 6i1. So what is the value of i1 by v2? i1 by v2 will come 1 upon 6. So you know the value of a c also. Okay, so what is the value of a now you have to calculate the value of a d. So for d, d will be what? D will be what? Minus i1 upon i2.
I2.
Yes. So minus I1 upon I2 while making V2 is equals to 0. So right, so you need to find the ratio between these I1 and these I2. Same thing you need to do, but the condition is what? Your V2 is 0. So form the KVL and get the results. So you will get 0 plus 2I2 minus 4I1 plus 10 I1 plus I2 is equals to 0. So you are getting what? See, this part will come what? 10 I2, 10 it will be 12 I2, and it is 6 I1 is 0. So it's a 2 only. So you are getting 2 I2 is equals to minus I1. So you need to find the value of minus I1 by I2. Minus I1 upon I2. You are getting 2. So this is the value of a D. So we know A, B, C, D parameter. The value of A is, the value of A, what we got the value of A?
13 by 6.
13 by 6, correct. 13 by 6. What is the value of a B? What value we got the value of a B? Anyone?
16, sir. 16.
16. Great. And C value is 1 by 6 and D value is 2. So by this way we got the value of a ABCD parameter, right? So till here anyone having any doubt? We'll jump to the next topic. If anyone is having any doubt, they can ask, or we'll move to the next topic. Vaishnavi, any doubt? Prasanna, any doubt?
No, sir.
See, for clearing this exam, you have to be regular and you have to be sincere. You have to put your effort. If you'll not put your effort, then it's going to be a very worst scenario. So be regular, and do practice and all. Do revise the topics very sincerely. Okay. At least give, means I am not saying that you have to give 10 hours or 12 hours. I am just saying if you will give your 6 hour also now, this you will be in a top 100. At least if you will give, means regularly, consistency is required. So just study consistently. Okay. Consistently you should give regularly 5 to 6 hours for this exam, at least, and maximum you can give, it's depend upon your wish. Okay, so we discussed that question, right? So 13 by 6, 16, 1 by 6, 2, that is the correct answer. Now find the Z parameter of the given below two-port network. Write the next question and solve it. If you understood this chapter, so you need to solve this question. Let me find the question. So yeah. So we completed this part. Okay, done. These things. Yeah, write the question. Find the Z parameter for the below given two-port network. Okay, so we have a two-port network like this, positive, negative. This is 0.3 V2 is 4 ohm and 0.2 I2. Okay, so these two are what? Dependent source. It's depending upon the voltage. Okay, 4 ohm, and here we have 10 ohm resistor. This is your two port network. So for two port network, one positive negative V1 will be this side and one positive negative V2 will be this side. I1 current will come and I1 current will leave. I2 current will come and I2 current will leave. So this part is your network, and this is your network. So network, this is your two port. So from this two port network, okay, from how to solve this two port network, and what you need to find? You need to find the Z parameter. So can anyone tell me what is the equation of a Z parameter? General equation of the Z parameter? What is the general equation of the Z?
Z1 to I2.
Yeah, okay. So V1 is equals to Z11 I1
I1
plus Z11 Z12 I2, and V2 is equals to Z21 I1 plus Z22 I2. So you know this particular equation, right? So apply this equation in this network and get the result. Okay. Command C. Okay. So yeah, if you will apply this, so how you will get the result? Okay. Yeah, how you will get the result if you will apply? Okay, you know now, you have a current 0.2 I2, right? 0.2 current I2. This branch current you know. Can anyone tell me what is the current will flow in this branch? If you know the current in particular flowing in this branch and particularly in this branch, so apply the KCL. Entering current, what is the entering current? I1 is the entering current. What is the leaving current? This is X you are assuming. So leaving current is two leaving current is there, X plus 0.2 I2. The value of X will be I1 minus 0.2 I2. So this branch current you understood. Okay, what about this branch current? If you want to find this branch current, so one X current is coming and I2 current is coming, so X plus I2 will be the current. X plus I2, what current will get? Put the value I1 minus 0.2 I2 plus I1 minus 0.2 I2 plus I2 is your this branch current. So what you are getting, I1 is equals to plus 0.8 I2, right? Please mic, please off your mic. Okay, so see, so we are getting I1 is equals to X plus 0.2 I2, X is equals to I1 minus 0.2 I2. What we did, we simply did I1 current is passing like this and 0.2 I2 current is passing from this. We subtracted this and we get the current in this particular branch. And similarly, if one current is coming in this branch and one current is coming in this branch, then overall the summation current will come in this branch, that is X plus I2, and substitute the value, you will get like this. Okay, is the thing is clear? Okay, if the thing is clear, then what you need to do, you need to apply the nodal analysis. Means you have this x, okay, this particular x, okay, and this is v2. This is nothing but this is v2 only, because nothing is connected. So this is v2 only, and this you are assuming as a x only, and this is the reference node. So how many nodes are there? One node, two node, and these all are combined. This is a 3 node. So we know the branch of this is assume this as a y, because we have taken x as a current. Okay, we know the value of x is equals to I1 minus 0.2 I2. Okay, the same current, if you want to find, just put the nodal analysis and get the result in this particular junction, So what you will get, or apply, or either apply the KVL. If you will apply the KVL, what you will get? Minus v1 plus 0.3 v2 plus y, because we are taking this as a plus minus y voltage, okay, overall voltage. So we are just taking, so y voltage is equals to 0. So what is the value of y? We are getting v1 minus 0.3 v2. We got the value of y is equals to v1 minus 0.3 v2. And one thing we can find, what is the current? X current can also be y minus v2 upon 4 is also x, this node minus this node divided by the voltage. But we know the value of x. What is the value of x? I1 minus 0.2 I2. And what is the value of y? We also know. Y minus v2 is equals to 4x. So put the value of y, v1 minus 0.3 v2, minus v2 is equals to 4, and put the value of x, I1 minus 0.2 I2. I1 minus 0.2 I2. So by substituting this, what you will get? You will get one equation, v1 minus 1.3 v2 is equals to 4 I1 minus 0.8 I2. Okay, you got one particular equation like this. Okay, now what we can do, we need to find some relations, or simply you can manipulate the circuit. Okay, let me discuss if you will apply the nodal analysis here. So what you will get? Minus v2 plus x plus I2 into 10, x plus I2 into 10 is equals to 0. So v2 is equals to what? X plus I2 into 10. Substitute the value of x, I1 minus 0.2 I2. So v2 you are getting I1 minus 0.2 I2 plus I2 into 10. So v2, what you will get the v2 value? This I1 minus 0.2 I2 plus I2, you will get 10 I1, this will become 0.8 and plus 8 I2. So these equations is similar to this equation now. v2 is equals to z21 I1 plus z22 I2. Am I right? v2 is equals to z21 I1 plus z22 I2. Second equation, v2 is equals to z22 I1 plus z21, and this is z22 I2. So you know the value of a z21, that is 10, and z22, that is 8. Okay, you got the result. Substitute this value, means this v2 value, this particular v2 value in this equation. So if you are substituting this particular value in this equation, v1 minus 1.3, v2 value is 10 I1 plus 8. Okay, solve it and just tell me the result. What we'll get? v1 is equals to minus 1.3 into 10 I1 plus 8 I2 is equals to, tell me the result, 4 I1 minus 0.8. 8 I2. Do it very fastly. What we'll get? Tell me the result. V1 is equals to what we'll get by solving this. I'm waiting. Prasanna, what we'll get?
Solving.
Yeah, trying. Okay, try it. Anish? What will get
Yes,
the...
sir.
Yeah, just try it. It's a very normal calculation here. So this is 8. Okay. This whole part will become as a positive only. 13 I1 will come. 8 into 13. So we'll get the result. This will be 10.4 I2 plus 4 I1 minus 0.8 I2. So V1 is equals to 13 I1, 4 I1, 17 I1 and 10.4 minus 0.8. What will get? 9.6. Correct? Is it correct? Sharon, is it correct?
Yes, sir. Yes.
Okay. So what is the value we are getting by seeing this? This is same as V1 is equals to Z11 I1 plus Z12 I2. So we got the value of a Z11 is equals to 17 and Z12 is equals to 9.6. So you got the Z parameter, that is 17, 9.6, Z21 is 10, that is 8. Okay, Prasanna, can you tell me this network is a symmetry network or reciprocal network?
Neither nor, sir.
Neither not.
Okay. How?
Because they both are not equal. Cross
Yeah,
value should be
cross
equal.
off diagonal. This element, what it say about reciprocity, and this will say about
Symmetry.
symmetry. If these two elements are same, then these elements, these matrices, these network are reciprocal. If these elements are same, then this network are symmetricity. So it is neither symmetry nor reciprocal. Okay. So the things we got the answer means like Z is equals to 17, 9.6, 10 and 8. Okay. So this two port network, another question. Write the another question for a two port network. See, it's a very easy. Either you can solve it like this. I told you na, make it as a make this circuit. Where is the equation? Yeah, you can solve like that also. Z11 is equals to what? V1 by I1. Put the I2 is equals to 0 and solve the equation and get the ratio of a V1 by I1. And either you can make equations in the form of this and simply calculate all the value. So it's depend upon you how you are solving. In the examination they won't ask to solve that much. They will just ask you find the value of a Z11 or H11 or H12 or H21. Only one value they will ask for a 2-mark question. Okay, so you don't need to solve all the things. For if they are asking you have to find Z12 only, what you will do? You will just simply you will substitute Z12 as a V1 by I2 and making I1 is equals to 0 and put the things in the circuit and you will get the result, your V1 by I1, like previously problem what we did in a previous problem. Okay, this part is clear to everyone? Okay. So in a next question, write find the z parameter. Wait. Find the z parameter. This is parameter. Find the z parameter. Okay, find the z parameter for the below given network, given two port network, that is two port network. Okay, so your network is this, is this, and this part, it's jumping over the circuit. These all are connected like this, and here I miss one resistance. Okay, so this is 1, this is 1 dash, this is 2, this is 2 dash, terminal 1, terminal 2. So what I mean to say you, this is your network, this is plus minus V1, this is plus minus V2, extending some part, some I2 current is coming, I2 current is leaving, I1 current is coming, I1 current is leaving, and the value is given as a 4, 5, 5, 4. So you need to find the z parameter. How you will do it? Anyone? What is the equation of a two-port network of a z parameter? V1 is equals to Z11 I1 plus Z12 I2, and V2 is equals to Z21 I1 plus Z22 I2. Okay, so same thing you need to do again. Let me yeah, okay. See, if I1 current is coming from here, and if your I2 current is coming from here, you are thinking there is some current X. So what will be the current in this? I1 minus X. Apply the KCL. This I1 will be subtracted by this X, so we will get I1 minus X. Okay, now what will the current in this? X is coming and I2 is coming, so X plus I2, because this is also coming, this is also coming, both will enter in this. Okay, so if X plus I2 is coming, what you will get here? This is leaving, this is leaving, so X plus I2 is coming and I1 is leaving, so you are getting X plus I2 minus I1, and here same current is coming, I1 minus X, this I1 minus X plus X plus I2 minus I1, you will get your I2. So we had applied the KCL is correct only. Okay, now what you have to do, to solve this port network? Nothing, you just need to find the value of X. Okay, how can you find the value of X? Apply KVL like this. So what you are getting, if you will apply KVL like this, this is minus V1 plus 5, and what is the current? I1 minus X. It's coming. What is the current? Your current is opposite to, means current is flowing like this, but you are taking a KVL like this, so it will be minus of x plus I2 minus I1 into 4 is equals to 0. So V1 value will come what? 5I1 minus 5x minus 4x minus 4I2 plus 4I1 is equals to that is V1 only. So we are getting this V1 value. So 5I1 minus 5x minus 4x minus 4I2 plus 4I1. What will be the result? What will be the result? V1 is equals to
minus 9x
minus 9x, okay. Minus 9x plus 9I1.
sorry 9I1
Yeah, 9I1 is there. Minus 9x is correct only, you had said. Minus 4I2.
minus 4
Yeah, we got the equation like this now. And if we need to find the value of x, what will the value of x? V1 minus 9I1 plus 4I2 is equals to 9x, right? If you substitute this, same thing what you have to do now, same thing, you apply a KVL in this particular like this, apply the KVL like this. Okay, if you'll apply the KVL like this, what you will get? Minus V2 and this you had applied the KVL like this, means current is you have taken the current and this is x, so you have chosen the opposite direction current, so it's minus x into 4. Okay, and this is the same directions, so this is I1 minus x, so I1 minus x plus I1 minus x into 5. Yeah, the thing is done. It's 0. So V2 value is coming what? 4x plus 5I1 minus 5x. V2 value is coming like this. So you will get V2 is equals to you will get to know V2 is equals to how much? V2 is equals to
minus 4x, sir.
minus 4x. See, this minus V2 is there, minus V2 we are taking. We have to assume the direction, means we have chosen the KVL like this. So this will come minus x into 4 plus this is I1 minus x into 5. If you solve this, V2 will come this side. Yeah, it's minus 4x plus 5I1 minus 5x. So you are getting minus 9x plus 5I1, this value. Okay, so you can do these things also. 9x you are getting as a V2. If you are getting a 9x minus V2 plus 5I1, the value of a 9x. So here 9x also here, 9x also here. Substitute and make means these equations are these two equations are same. So V1 minus 9I1 plus 4I2 is equals to minus V2 plus 5I1. So what the general equation will get? V1 plus V2 is equals to 9I1 minus 4I2 plus 5I1. So V1 plus V2, what we are getting? 14I1 minus 4I2. This part is clear. V1 plus V2 is equals to 14I1 minus 4I2. This part is clear for everyone, or still having any doubt? And this. Prasanna, it's clear? Sharon, it's clear? Or you have facing any doubt? If you are facing any doubt, you can ask. Okay. So we are getting V1 plus V2 is equals to 14I1 minus 14I2. So the thing is, now the general equation is v1 is equal to z11 I1 plus z12 I2, and we got the equations like this: v1 plus v2 is equal to 14 I1 minus 4 I2. So how we'll get the value? How we will get the value? How we'll get the value? We have another equations like this loop. You are seeing this particular loop. Let me yeah, you are seeing this particular loop. Let me take another point. Yeah, you are seeing this particular branch, this particular branch, this is making as a closed circuit. Have you seen this? We are having a closed circuit like this. This is moving like this, this is moving like this, this is moving like this, and this is moving like this. So we can make one equations from here also, right? So what will be the current equation we'll get? We have X current here, right? We have X current here, and we have I1 minus X current here, I1 minus X current here, and we have X plus I2 minus 1 current here, I2 minus 1 current here, and in this branch we have X plus I2 current, X plus I2 current. Make the KVL like this. So what will give? What will get? 4x plus 5x plus I2 plus this branch current. What is the directions taken? So we are taking like this, and the current direction is this only, and we are getting 4x plus I2 minus I1, and this is the opposite direction. This 5 ohm current is taken like this, but we are moving like this. So minus 5 into what is the current in this? I1 minus X. I1 minus X is equals to 0. Solve this and get the result. 4x plus 5x will get 9x plus 5 I2. 4x plus 4 I2 minus 4 I1 minus 5 I1 minus plus 5x. So what the things we are getting? 4x plus 4x is there, 4x plus 5x, 9x we are getting, 5 I2 we are getting, 4x we are getting, 4 I2 we are getting, minus 4 I1 we are getting, minus 5 I1 we are getting, and plus 5x. So these 9x and these 9x will make it 18x. 5 I2 plus 4 I2 will give you 9 I2, and the next one this is minus 9 I1 is equals to 0. So you are getting what? The value of a 18x is coming what? 9 I1 minus 9 I2. You are getting the another value, and if you will take 2 common, suppose if you are taking 2 common, what was the previous value we got? If you will take 2 common, I am just taking 2 common, 9x, so it will be 9 by 2 I1 minus 9 by 2 I2. So these equations can be equated with this particular equation. V1 minus 9 I1 plus 4 I2 is equals to 9 ix. So V1 minus 9 I1 plus 4 I2, V1 minus 9 I1 plus 4 I2 we can equate with this 9 by 2 I1 minus 9 by 2 I2. You will get to know the answer. So 9 I1 and 9 by 2 I1 will give you what? 18 plus 9, 27. 27 I1 by 2. And this minus 9 by 2 and minus 9 by this is 4. So what you will get? 8 or 9? 8 or 9 minus 17 by 2 I2. So you got your answer. This particular thing is done. And same thing you have to do with a different equation. This 9 x is equals to minus v2 plus 5 I1. So equate the same thing, 9 I2 minus I1 minus 9 by 2 I2 with a different equation, that is minus v2 plus 5 I1 minus v2 plus 5 I1. If you will solve this, what you will get? v2 is equals to 5 I1 plus 9 by 2. So what the result you will get? 19. So this, if solve it and just tell me the answer. If you solve these equations, what you will get? V2 will come what? 9 by 2 I1 minus 5. What you will get? Minus 1 upon 2 I1 plus 9 by 2 I2. We'll get this na? 5 minus 9 by 2. Yeah, we'll get that. We'll get this only. So 9 by 2 minus 5, we are getting minus 10 plus 9 is minus 1 by 2. And this is, let me do it for you. Means for, okay, V2 we are taking this side, 5 I1 we are taking this side, minus 9 by 2 I1 we are taking this side, and plus 9 by 2 I2 we are taking this side. So it's not, it will come in plus. So it will be 1 by 2 I1 plus 9 by 2 I2. So what we got the results? V2 is 1 by 2 I1 plus 9 by 2 I2. So Z parameter is coming. Z11 is 27 by 2. Z12 is minus 17 by 2. And Z22 is 1 by 2. 1 by 2. Z11, Z12, Z21. Z21 is 1 by 2 and Z22 is 9 by 2. So by this way we can solve this question. It seems to be a very simple, but it's not very simple, right? Actually we committed some mistake by solving this. Wait, let me do it, because we'll get here, I think we'll get here 1 by 2. What the things we committed mistakes? Let me see. So V1 is equals to V1 minus 9 I1 plus 4 I2 is equals to 9x. So we equated that V1 minus 9 I1 plus 4 I2 is equals to, yeah, okay, 9 by 2 is there. So 9 by 2, if we'll solve this, what we'll get? If this is coming, so we are getting 27 by 2. That is correct. That is okay. Guys, do one thing. Just check the V1 equations. This V1 equations. Whether we did it, whether we formed the equation right or wrong. This V1 equation. This is minus V1 plus 5 I1 minus x, and this is minus x plus I2 minus I1 is into 4 is equals to 0. We solve this, 5 I1 minus 5x minus 4x minus 4 I2, and this minus is become 4 I1. That is correct only. And that with the yeah, V1 we are getting this minus 4x minus 9x we are getting, this 9 I1 we are getting, okay, minus 4 I2. Up to here it's correct. Then what is the problem? And 9x value we are getting minus V2 plus 5 I1. So that part is okay, that part is clear. And 18x plus 9i2, 9x we are getting 9 by 2 minus 9 by 2. So if we are equating this, wait, okay, okay, just check it, means because the answer we are getting it's wrong. This value is correct, this value we are getting it's right, but this two value it's coming wrong. Just check it once again. Prasanna, what will be the KVL equation in this? If we will solve the KVL equations, we are having a current I1, right? Current I1 is there, and this is X is there. So I1 minus X will be, I1 minus X will be there only. This is 5. So if we will form the KVL equations, so what we'll get, minus V1 plus 5 I1 minus X, and this we took X plus I2 minus this we took minus X plus I2 minus I1 into 4 is equals to 0. So V1 value will, what the V1 value will get, 5 I1, this 5 I1 minus 5x minus 4x minus 4 I2 plus 4 I1 is equals to 0. So V1 value will get 5 I1 minus 9x minus, that is 5 plus 4, 9 I1 minus 9x minus 4 I2. So that things only we got na. V1 is equals to minus 9 I1. So why it's coming wrong? Yeah, I got it. The thing is V1, yeah, what was the wrong things? I got it. See, this is V1 is equals to 9 I1 minus 9x minus 4 I2. So what the value for V1 will get? V1 will get, or 9x will get minus V1. We missed this point.
0 minus 9.
Yeah, we missed this point. So if we want to find the value of a minus 9x, so 9x will get minus V1 will be there. So a small mistake, minus V1 plus 9 1, we are minus V1 plus 9 1 minus 4 I2. So this is the value of your 9x. So this is the correct equation. So we just missed the small mistake. So see, the small mistake will do these things. Okay, so 9x value was what? 9 by 2 I1 minus 9 by 2 I2. 9 by 2 I1 minus 9 by 2 I2 is equals to minus V1 plus 9 I1 minus 4 I2. Now solve the equation and get the result. V1 will be 9 I1 minus 9 by 2, it will be 9 by 2 I1, and this 9 by 2 minus 4, so it will give you 1 by 2 I2. So this is the correct equation. So 9 by 2 I1 plus 1 by 2 I2 you will get. Okay, so this part is wrong. So you are getting 9 by 2 and 1 by 2. So can anyone tell me this network is a symmetry or reciprocal? We are getting the Z parameter as 9 by 2, 9 by 2.
Reciprocity.
It is both. See, this part is equal, 1 by 2 is coming equal, and this part is also coming equal. So it is reciprocal also and symmetry also. Okay, now I will tell you the shortcut how to do this kind of a problem. This is a very long cut method. So write the next topic. See, this much time you don't have in a gate to solve like this, means forming the equations and all. It's taking a huge amount of a time, and there is a chances to do mistakes. So what I had committed, see in this particular equation, what I had committed. This is v1 minus 9x plus 9i2. So this small mistake can make you a blunder. So see, I missed that minus sign. We are getting the value of a 9x. So minus sign was there, and this was plus 9, and this could be a minus 9. So I just missed the minus sign, and we got the wrong answer. So because of that small mistakes only. So write the next topic, which will make you a very easy to solve this network in a very easy way. Write the lattice circuit. The topic is lattice circuit. Okay, so suppose you have ZA network, and in down you have ZT network. Okay, this is ZC network, and this is ZB network. This is your two-port network only. Okay, two-port network. So I'm not writing v1 v2 and all. So this kind of a network, we were having the same structure na. See, we were having the same structure na. This is ZA, this is ZD, and this is ZB, and this is ZC, right? If this kind of a network you can see na, you can simply make if ZA is equals to ZD, and if ZB is equals to ZC, if this condition is there, then the network will be symmetry. Directly you can say. Or for finding the value of a Z11 or Z22 will be what? ZA plus ZB by 2. And for finding the value of a Z12 and Z21, the value will be what? ZB minus ZC by 2. So what was the value? Means 4, 5, 5, 4. 4. This is 4, and this is 5. Okay, this value is 5, and this value is 5. Substitute and just tell me what you guys are getting. This is 4, this is 4, this is 5. So Z11 what we'll get? 4 plus 4. 4 plus 4 by 2. ZA plus ZB. 4 plus 5.
4 plus 5 by 2.
9 by 2.
9 by 2.
And what we are getting here? Z12 and Z21. This minus this. ZB minus ZC. So let me check it once again. Oh, sorry. I ZB minus, this is ZA. ZB minus ZA. ZB minus ZA. So the formula is ZB minus ZA. Okay. So what you will get? ZB, B minus A, 1 by 2. You got directly answer. 9 by 2, 1 by 2, 1 by 2, 9 by 2. Is this part is clear? This formula is clear. Z11 or Z22 is ZA plus ZB by 2, and Z12 is equals to Z21 is equals to ZB minus ZA by 2. And how is the structure? This is Z, this upper one is ZA, this lower one is ZD, and this first port network wire is ZB, second port network wire is ZC. This concept is clear to everyone, or is anyone is having?
It also satisfies reciprocity, right?
Yeah, it is satisfying the reciprocity and symmetricity both. Anis, it's clear for you, or you are facing any doubt?
Yes, sir.
Okay, Anis.
No, sir, no doubt.
Okay. And the same thing is applicable, means like if you have a Y network, okay, like this, they can give you a ZA or ZB or ZC or ZD. If they are giving you YA, YB, YC, YD, so same formula will be applicable for Y parameter also. For Y parameter also. What is that? YA is equals to YD, YB is equals to YC, symmetry. Okay, and Y11 is equals to Y22 is equals to YA plus YB by 2, and Y21 is equals to Y12 is equals to YB minus YA by 2. Okay, so same things you have to apply, same formula you have to apply, YA plus Y by 2, YB minus YA by 2. Okay, now write the next topic, that is Bartlett bisection theorem. So we are at 131 page. Out of 394 page we had covered 131 page. This is the means like what I am giving you na, in a means a highest paid coaching center na, these notes you will get. Okay, all the topics I am covering, I am not leaving single topic, means I am covering all the topics, all the important parts. So apart from the GATE, you are getting the things, means like a ESC examinations and all, every topic is covered. Okay, so write the next topic. Bartlett bisection theorem. Bisection theorem. Okay, theorem. So what is Bartlett bisection theorem? See, this theorem na, this theorem is applicable for designing the lattice network. Okay, so it is used, write it down, it is used for the designing, it is used for the designing of the lattice network. Okay, so first things, it is applicable only in a symmetrical network. It is applicable only in symmetrical network. Okay, so in a Bartlett bisection theorem, what we do? In a Bartlett bisection theorem, we separate given network into two equal parts. Write it down, into two. My pen is stopped working. Into two equal parts. Okay, and then we bisect from the middle into two equal part, and then we bisected from the middle. Okay, so see, if you have a network, symmetrical network, if you have a network like this, and this is your first part, you have to check the either the network is symmetry or not. Okay, if the network is symmetry, then what you have to do, you have to make the half the network. Okay, half network, and half network this side. Okay, third, you have to take this half network only, consider this half network. I will show you with the example. And in this half network, you need to find, this is n half network, you need to find open circuit parameter ZOCH. Okay, while making I2 is equals to 0. And B part, you need to find short circuit parameter while making these two port as a 0, means V2 is 0, so that is known as a short circuit parameter, ZSCH. So short circuit. Okay, and this is open circuit network. So you got two things, ZOC and ZSCH. Now what you have to do, make the network like this. This will represent ZSCH. The lower one will represent ZSCH, and these two will represent your ZOCH. ZOCH. Okay. So basically, Z11 will be what? ZOCH plus ZSCH by 2. And Z12, this is equals to Z22 also. Z12 is equals to Z21 will be what? ZOCH minus ZSCH by 2. Same formula we are getting. Now see how we'll get the results of a means Bartlett. So this is just important things what I had given to you. So I'll show you how we'll get. Suppose, yeah, okay, So thing is means this is just a theory part. So you have to remember these things. Bartlett bisection theorem is how we can do it, is used for designing the lattice network. This part you should remember. For designing the lattice network, what concept is used? Bartlett bisection theorem is used, or it will only be applicable to a symmetrical network. This is also important. It is only applicable to symmetrical network. Or in a Bartlett bisection theorem, we separate a given network into two equal parts. What we do? We are separating this Bartlett bisection into two equal parts. So let me show you some example. Then you will understand very clearly. Yeah. Suppose in the note it is not given, so write it very carefully. Suppose you have a network like this. Okay. This is, I'm taking some random value. Okay. So this is 2. Oh, wait, my pen is stop working. Yeah. This is 2 ohm. This is 2 ohm. And this is 4 ohm. So by placing, if you will place one mirror, you will see the same thing. Same replica is representing either in this side or this side, right? So this is your network. Now what you have to do? You have to divide this network into two parts. So how can you do it. This 2 ohm is there. You can make it as a 8 ohm parallel with another 8 ohm. So these 8 will give you result what? It will give you the result 4 ohm only. This is 2 ohm. This is. So now bisect. This is the representation. This is same. We make this 4 ohm as a 8 ohm. Okay. Now what you have to do now is make the network in a 2 sections. So you are getting 2 half network half, another network half. So what is the network half? This part is network half. So NH representing what? This particular, this is your NH. This is 2, this is 8. So what I am telling, you are assuming this is a V1, this is your I1, this is your I2, and this is your V2. Now you are assuming like this. So what is the things means you have to find the value of ZO open circuit. So what is Z open circuit? Open circuit means your I2 current is 0. So what is ZOC? Simply V1 by I1. So V1 by I1 means apply the KVL, minus V1 plus 2I1, and I2 is 0, so it will be 8I1 is equals to 0. So V1 by I1 what will get? 10 ohm, or just add it, it's a series resistance, it will be now. I2 is 0, so that is. Now the next step you have to find ZS, Z short circuit. So for finding the Z short circuit, this is 2, this is 8, this is positive negative V1, this is I1. Now you are finding ZSCH, short circuit, SCH. So short circuit, what you are doing? You are making this as a short circuit. So what? The current will directly go, because current will always follow the shortest path. So it will directly go. This 8 ohm will become redundant, no use. Or apply the KVL or get the result V1 by I1. Minus V1 plus 2I1. This is no resistance, that is 0 is equals to 0. So V1 by I1 is 2 only. So this will become the redundant part, and you are getting the open circuit, that is short circuit, as a 2 ohm. Okay. Now you got the value of open circuit and short circuit. So your latest network is done. This is open circuit, this is short circuit, sorry, and this is also short circuit, and this two is, and this particular two open circuit. This is open circuit, ZOCH. So what is the value we are getting? The network will be, open circuit is what? 10 ohm. Short circuit is 2 ohm. This is 2 ohm. This is 10 ohm. So 10 ohm. So you made it your 2-port network. That is lattice network you designed. You designed the lattice 2-port network. This part is clear? How we did it? Or anyone having any doubt? Anish, it's clear?
Yes, sir. Now clear.
Prasanna, it's clear? Sharon, it's clear? Vaishnavi, it's clear?
Yeah.
Okay. So we had completed up to this. Now I am giving you one question. Hey guys, please try the numericals what I had shared with you in a group, that workbook problem. One day we'll discuss all the problem. Okay. So just you just first I am giving you this 4-5 days time. In this 4-5 days time, you have to finish all the 50 problem of the basic chapter 1. Okay, and we'll discuss all the 50 questions in the class. Okay, first at least you have to try. If you will try, then only you will have some interest by seeing the answer also. Okay. Okay. Now the second question is, you have to find the y parameter. So what is means you already know, we already studied the y parameter. Okay, so write the question. It's a very simple question, very simple question. Find y parameter. Okay, you need to find the y parameter of this particular circuit. This is given as a z, and this is given as a I2, and this is given as a I1. This is positive negative V1, this is positive negative V2. So what is the general equations of a y parameter? Vaishnavi, what is the general equation of a y parameter?
I1 equal to
I1 equal to
y11
y11
v1
v1
v1 plus y12 v2
y12 v2
I2 equal to
y21 v1,
y21 v1
yes,
plus y22 v2.
y22 v2. So this is the general equations of your y parameter. Okay, now what you need to do, what will the current means you have this particular, you having this voltage is here, this voltage is here, then what is the current of this? I1 is equals to what? V1 minus V2, V1 minus V2 upon Z, V1 minus V2 upon Z. So what you are getting, I1 is equals to V1 by Z minus V2 by Z. Now you want to find the value of I2. I2 will be what? V2 minus V1, V2 minus V1 by Z. If you are seeing from this side, so first this voltage will come and it will subtract from this voltage, you are getting V2 minus. So what you are getting the equation, minus V1 by Z plus V2 by Z. So see, compare this from and compare this from this. What is the y parameter you are getting? Y11 is 1 upon Z. Y12 is minus 1 by Z. Y21 is minus 1 by Z. And Y22 is 1 upon Z. It's clear how we solved it? So it's very simple. It's very this concept is going to be used in a power system. Okay, so remember, means while studying the power system subject, we'll use this very much. This, while no circuit is given, you having a V1 means a port like this, V1 is here, V2 is here, I1 current is going, I2 current. This is what? I1 is nothing but I1 is equals to minus I2. This kind of means nothing is, it's all open. So you directly you can make the transfer function, means your y parameter is like this. Z is 1 by Z, 1 by Z, minus 1 by Z, minus 1 by Z. Okay, 1 by Z, 1 by Z, minus 1 by Z, and minus 1 by Z. Vaishnavi, it's clear?
Yes, sir.
Or any doubt? Anis, any doubt?
No, sir.
Priyanka, you have any doubt? Sharon, you have any doubt?
Clear, sir.
What is the doubt? Or it's clear?
Clear, sir.
Okay, it's clear. So fine. So this kind of a questions will be solved like this. Okay, so y parameter you are getting. So can anyone tell me, means is this network is reciprocal or symmetric? See the branch. If you are getting the both, yeah. If you are getting the diagonal equal, means this is applicable for z parameter and y parameter only. Remember this thing. This z11 and this we are checking for, this things is checking for, we are checking for symmetricity, and this we are checking for reciprocity. So this is both. Can anyone tell me what will the value of z parameter? You know the value of a y parameter. 1 upon z, 1 upon z, minus 1 upon z, and minus 1 upon z. Can anyone tell me what will the value of a z parameter? Z parameter is
Y inverse.
y inverse. So just solve it and give me the result. What will get? What you will get? Y inverse. If you'll solve it, what you will get? What is the determinant of a z? What will be the determinant of z? Determinant of z?
0.
0. If the determinant of a z is 0, then y inverse cannot be found. Because for y inverse, you are dividing this circuit, this particular, by, for getting the y inverse, you have to divide it by determinant of a z, right? So you will not get the z parameter of this network. Okay, because y parameter means you are doing the inverse, means you are making you are making z is equals to y inverse. So inverse matrix, what? It is coming this side, it is coming this side, it is 1 by z only, it is 1 by z only, sine is getting 1 by z and 1 by
All
z.
1 by z.
Yeah, divided by 1 by determinant of z. So it is 0. So it's coming like what? It's coming like a infinity, infinity, infinity. Yeah, so this we cannot find the y parameter in this circuit. Same thing applicable for z parameter. If you have some y parameter, y11, y12, y21, y22, but your y determinant is 0, then you cannot find the z parameter. This part is clear?
Yeah.
Okay. If it is clear, so yeah, if it is clear, then fine. Or we can say the thing is yes, let me give you a okay. Okay, now find, do one question. You guys have I'm giving you 5 minutes and solve this question. It's a very simple question. This is 2 ohm, this is 6 ohm, this is 4 ohm, this is positive, negative, V1, this is positive, negative, V2, I1, this is I2, this is 2 ohm. Okay, so V1 is here, V2 is here. You need to find the z matrix, z parameter, means your z matrix. Solve it within a 5 minutes. It won't take that much time also. Anis, solved it.
Yes, sir. Yes, sir.
Solve it. Anyone solved it?
Z11 value is 6.
Z11 value what you are getting?
6, sir.
6. And Z12?
Yeah.
4.
Okay. And Z21?
4, sir.
4 you are getting. And Z22?
10, sir.
Okay.
7.
Fine.
Yeah.
Everyone is getting the this answer? Yes. Okay. So see, I1 is here, I2 is here. Okay. So what will the current I1 plus I2? I1 plus, this is I1 plus I2. So make the KVL and get the result. V1 is equals to 2I1 plus 4I1 plus I2. So you will get 6I1 plus 4I2. Same thing you have to do in this branch. V2 is equals to 6I2 plus 4I1 plus I2. So V2 you will get 4I1 plus 10I2. So you are getting the results like 6, 4, 4, 10. So this network is reciprocal or symmetry. This network is
Reciprocal, sir.
reciprocal. Great. Reciprocal. But it is not symmetry because this value is not same. So it is not symmetry. Okay. So we completed our two-port network. Now we'll go for, so in a two-port network, anyone having any doubt? So I am giving you a crux view for a two-port network. Just you have to remember this particular, write it the note. Z parameter we have. So Z, for a Z parameter, what is the equations? V1 is equals to Z11 I1 plus Z12 I2. V2 is equals to Z21 I1 plus Z22 I2. Okay. This is for Z parameter. For Y parameter, we have I1 I2 is equals to Y11 I1 plus Y12 I2 and Y21 I1 plus Y22 I2. This is Z and Y parameter. Your H parameter, V1 is equals to H11 I1 plus H12 V2 and I2 is equals to H21 I1 plus H22 V2. So this is your H parameter. What about Z parameter? For G parameter, you have I1 is equals to, wait, I am writing here G for G parameter. I1 is equals to G11 V1 plus G22. This is 1 this is 1 2, yeah, 1 2. This is 1 2 G12 I2 plus V2 is equals to G21 V1 plus G22 I2. So this is your G parameter. What about ABCD parameter? ABCD parameter or transmission line parameter. What we have for ABCD parameter? V1 is equals to AV2. Prasanna, what is the formula for ABCD parameter? Whether it will be V1 or it will be V2. V1 is equals to AV2 minus,
DI2.
yeah, and I1 is equals to CV2 minus
CV2 minus DI2.
DI2. So these I2 means what? I2 is equals to minus of IS, and yeah, this is the things you should know, because in a ABCD parameter we have a transmission line ABCD. This is I1, this is I1, and this is I2, this is I2. So here this is receiving, sorry, IR. This is I2 is equals to, so means here IR is like this. So I2 is just opposite to receiving end current, and I1 will be same as IS. Okay, so I2 is equals to minus IR, or V, and V1 is equals to V sending end voltage, and V2 is your receiving end voltage, VR. Okay, so this was the this was the story of a two-port network. And you should also know, you learn the concept now, what is Z11. Z11 is equals to V1 by I1 while making I2 is equals to 0. Just do this, just manipulate this, and you will get all the answer very easily for your Z parameter, Y parameter, H parameter. There was one relations, means your Z parameter is nothing but your Y inverse. Okay, Y inverse. And if you have a y parameter, you can find the Z parameter easily. Y is nothing but your Z parameter inverse. Same thing applicable for H and G. H is the inverse of a G parameter and G is the inverse of H parameter, right? H is inverse of G parameter, or you can write G is inverse of H parameter, and ABCD is the common, that is called as a transmission line parameter. So up to here it is clear. We discussed the lattice theorem, we discussed the Bartlett sections, how to make a lattice network using the Bartlett's theorem. So these things is clear for everyone. Okay, so write down the next topic. Interconnection between two-port parameter. So interconnection between two-port parameters. Okay, this is very much important. So first one is T parameter to Z parameter. How is your T parameter is related to Z parameter? Write it down. T parameter to Z parameter conversion. How you will convert your T parameter to Z parameter? Okay, so see, what was the equation of a T parameter transmission line parameter? It was V1 I1 AV2 minus BI2 CV2 minus DI2. This was the equation of your T parameter. What was the equation of your Z parameter? V1 V2 Z11 I1 plus Z12 I2 and Z21 I1 plus Z22 I2. Okay, now for finding the value of a you need to find the value of a Z in terms of ABCD. So how can you do it? You have to make this as in this form. How you will do it? So instead means like you have to get the value of you are knowing now this value. See, V1 is equals to, you need to convert this V2 value in terms of I1 value. Here I2 is there. Okay, so you need to convert this V2 value in terms of I2 value. How can you do it? So I1, just find the value of a V2. So I1 plus DI2 is equals to CV2. From this we we will get this. Everyone getting this? CV2 is equals to what? I1 plus di2. What is the value of a V2? I1 by C plus D by C into I2. Clear? Anis, it's clear? We are getting V2 value is
Yes, sir.
I1 by C plus D by C into I2. And these value we can
Yes, sir.
substitute in this form. V1 is equals to A. We can if you substitute the V2 means I1 upon C plus D upon C into I2 minus B I2. What you will get? Just solve the equation and what you will get? A by C I1 plus I2, take the I2 common, you are getting D minus BC upon C. Right? AD will come because A is common, na? So AD is come. AD. So V1 what you are getting? A by C I1 plus I2 AD minus BC upon C. So what is the conversion? Means your Z11 is nothing but A by C and your Z12 is nothing but AD minus BC by C. Z12 is nothing but AD minus BC by C. This is clear, Prasanna, Vaishnavi? Or still having a doubt?
Right, clear.
Clear. Okay. So we are getting AD minus BC upon C. Anis, it's clear? How we
Yes,
are
sir.
getting Z11 is equals to A by C and Z12 is equals to AD minus BC by C. Now the same thing you have to do in the equation 2. Means see, you need to find the V2 value in terms of I1 and I2. So V2 is here. Okay, I1 is also here and I2 is also here. Just manipulate and get the result. This is your equation 2. How you will get? CV2 is equals to I1 plus di2. V2 is equals to what? I1 by C plus D by C I2. So what is the value of a Z21? Z21 is 1 upon C. What is the value of a Z22? It is D by C. It's clear. How we did it? It's clear? Prasanna, it's clear?
Yes, sir.
So what you are getting means if you want to write a Z parameter in terms of a ABCD parameter, what is Z11? A by C. What is Z12? AD minus BC upon C. What is Z21? 1 upon C. And what is Z22? D by C. Priyanka, it's clear?
One second, sir.
See Priyanka, what we did now, we you know now what is the transmission parameter. V1 is equals to AV2 minus BI2, I1 is equals to CV2 minus DI2, right? So what we have to do now, we have to convert this T parameter in terms of a Z parameter. And what is the equation of a Z parameter? V1 is equals to Z11 I1 plus Z12 I2 and V2 is equals to Z21 I1 plus Z22 I2. So what I am just trying to convert these equations in the form of this equation. So if you want to get in the form of these equations, so here we have a V1 value, here we have a I2 value, that is okay. V1 value is okay, that I2 value is okay, but we don't need V2 value, we need I2 value. So with the help of our second equations, we will get the value of a V2. Manipulate this I1 plus di2 divided by this minus di2 will go to the left hand side and you will get the value of a V2, that is I1 by C plus D by C I2, and put the value in the first equation. So you will get V1 is equals to A into I1 by C plus D by C into I2 minus B I2. And after solving this, you are getting one result like this: A by C I1 plus I2 is equals to, that is A, AD minus BC by C. So this equation is similar to your first equation of the Z parameter, right? So what is the value of Z11? Compare this and this. So Z11 is coming as a by C. Z12 is AD minus BC by C, right? Priyanka, is clear now?
Why we can't take the first equation and substitute in the second equation?
Why? Hello.
Why you have taken only second equation? Why not the first one?
You can do with the first equation also. See, here in the second equation we have the v1 value, not na.
No.
So we are not having the v1 value. We are considering the first equation. We will see the second equation also. For the second equation, second equations we need to get the value of a v2. So directly we are getting the I1 is equals to cv2 minus di2. Just simply if you will put I1 plus di2, and you are getting cv2. So you are getting the results from these equations. v2 is equals to I1 by c plus d by ci2. Directly you are getting. So these can be compared with this. So this is your z21 is equals to 1 by c, and z22 is equals to d by c. Prasanna? Any
Yeah,
doubt?
got it.
Got it? So
Yeah.
we just manipulated with the equations. What I am trying to say now, this equations of a transmission line you have v1 is equals to a v2 minus bi2 and I1 is equal to c v2 minus di2. You just need to convert in the form of like this. Make this equation in the form like this, and you can easily do with the help of these two equations. Just get the results. So means I'm saying this is your equation 1, this is your equation 2. From these equations 2 you get the value of a v2, and this v2 value is substituted in this value, and you are getting the same equations like this, right? You are getting the I1 value and you are getting the I2 value. Here we have the I1 value, here we have the I2 value, and this rest of a by c, ad minus bc is directly compared to z11 and z12, right? Priyanka?
Yes, sir.
Okay. Sharon? Vaishnavi? Anish? Any doubt?
Clear, sir.
No, sir.
Okay, great. So like this way means directly they will give you a ABCD parameter, and you need to find the value of a Z parameter. So like that you can solve it. Okay. Okay.
Okay, sir.
Okay. So see. Yeah. Okay, now just get to know this thing. Everyone know we already discussed the property of a symmetry and reciprocity. Wait, someone is coming. Okay. We already discussed the property of a symmetry and reciprocity. For symmetricity, what was the condition? Z11 is equals to Z22. And for reciprocity, what was the condition? Z12 is equals to Z21. Now, what is the value of a Z11? A by C. And what is the value of a Z22? D by C. If your A is equals to D, means you have a transmission parameter that is A, B, C, D. And if your A is equals to D, then the network is symmetric. Same thing you have to do for this Z12. What is the value of a Z12? AD minus BC upon C. And what is the value of a Z21? It's 1 upon C. So that means if AD minus BC is coming 1, AD minus BC means what? It is a determinant. AD minus BC is a determinant of a transmission parameter. So if determinant of a transmission parameter is 1, then the network is reciprocity. Okay. So you know we already discussed for see, I am giving you this thing is clear for everyone how we are getting the what I am telling. You have a T network, you have a transmission network, and this network is given as a B, C, D. You know the conversion, how to convert this transmission network into Z network. And by converting this Z network, you are getting the equation like A by C 1 by C, A by C 1 by C, D by C, and AD minus BC upon C. So you are converting this in this process, by this process, V1 is equals to A V2 minus BI2, I1 is equals to C V2 minus DI2, and V1, and this is the equation of Z parameter V1. And now you are manipulating and you are converting and you are getting the result like this. For Z parameter, this is what? This is representing your Z11, Z12, Z21, Z22. So for symmetricity, we are considering this part. This is for symmetricity. If these two are equal, and for reciprocity, we are considering this part. If Z11 is equals to Z22, the network is symmetricity. If Z12 is equals to Z21, the network is reciprocity. Okay. In sometimes they will directly give you a question like you have a ABCD parameter, ABCD parameter. Then you don't have a time to get solve the equations and get the results of a Z parameter. So what you will do, you will use this conversion. Means your Z parameter is directly A by C, 1 by C, AD minus BC by C, and D by C. And what you will check? You will check if these two are equal, then network is reciprocal. And these two are equal, then the network is reciprocal. So and if you are getting the directly the transmission parameter, so it's taking time. You need to convert this in the Z parameter, then you are checking this ratio is same or not, these things are same or not. So directly we are forming one result. What the results we are getting? A by C is equals to D by C. Means in a transmission network, if A is equals to D, that means the network is symmetry. Okay. How? Because your here Z11 is what? A by C, and Z22 is what? D by C. For symmetricity, Z11 is equals to Z22. So A by C is equals to D by C. These are cancelling out. So if A is equals to D, then the network is symmetricity. Same thing you will see for this B or C. Here the thing will not apply like this. It is applicable only in the Z parameter. For reciprocity, AD minus that Z12 is equals to Z21. Now put the value of a Z12. AD minus BC by C is equals to 1 by C. That means what? AD minus BC, AD minus BC is what? It is your determinant of a transmission parameter, transmission line parameter. So you are getting what? If the determinant is 1, then the network is reciprocal. Prasanna, it's clear?
Yeah.
Everyone? Priyanka, Sharon, Vaishnavi, Anish?
Yes, sir.
Yes, sir.
Okay. So this thing we had completed. So, and it's very important that what I told you right now, it's a very important, and this concept they are asking many times in a GATE examination and several PSU examinations. You will find they will give you a directly ABCD parameter, and you have to use this concept. Okay. While solving the questions and all, you will understand in a much better way. Okay. See, the same thing we'll do for if you want to convert your H parameter to Y parameter. What you will do? If you want to convert your H parameter to Y parameter, what you will do? See. So you need to second is you have to convert H parameter into Y parameter conversion. So what is the general equation of a H parameter? V1 is equals to H11 I1 plus H12 V2, and I2 is equals to H21 I1 plus H22 V2. This is your equation 1 and this is your equation 2. What is the general equation of a Y parameter? I1 is equals to Y11 V1 plus Y12 V2, and I2 is equals to Y21 V1 plus y2 to v2. Now
Why we are only considering H and Y combination? Why not with Z or T something?
z or
Why only H and Y?
see, the conversion for this type of network, na, conversion is very similar. So that's why, means for if you will convert for Z and T, na, it will take a lots of means what to say, you cannot find, means it's a very difficult to find. For this there is a probability, means you can get the equations very easily. That's why we are making the short tricks. Okay.
Oh, okay, that's why we are considering
Yeah,
only
yeah,
particular
that's why we
combination.
are considering Z and Y, because we can convert it very easily. So we can use these things, we can use as a tool in an examination. Okay, directly.
Yeah.
So see, so we have H parameter, we have Y parameter. So see, you have the Y2 equations in the form of V1 and V2. Here V2 is here, but we need what? We need V1. Okay, so what you will do, just find the value of I1. So how you will get the value of I1? V1 minus H12 V2 is equals to H11 I1. So I1 value will be 1 upon H11 V1 minus H12 divided by H11 V2, and substitute this equation 3 into equation 2. What you will get? I2 is equals to H21 1 upon H11 V1 minus H12 H11 V2 plus H22 V2. Solve this and get the result. What the results you are getting? I2 is equals to H21 by H11 V1. Now taking V2 as a common, you are getting H11 into H22 minus H21 into H12, right, divided by H11. So this equations we got now, I2 equation. So Y21 is what? Y21 is your what? H21 divided by H11, and Y22 is what? H11 into H22 means you have a H parameter, H11, H12, H21, H22. So what is this? H11 into H22 minus H12 into H21. It is determinant of H parameter divided by H11. So we got these combinations, right? It's clear? Prasanna, it's clear how we get the result? Vaishnavi, it's clear? Or any doubt? Priyanka, any doubt? What we are doing here? We are just simply substituting the equation V1 is equals to H11 I1 plus H12. We know the particular equation. We know the particular equation of a Y parameter. And we are just converting this in the form of a this, and comparing after getting this, and we are comparing the original equations, general equation. So we are getting the equation like this. Okay. Now the same thing. See, in the first equation, you need to form the equation in the form of I1, V1, V2. We have I1, we have V1, we have V2, but you have to manipulate in this form. So what you will get? See, V1 is equals to H11 I1 plus H12 V2, right? And for this is for H parameter, and for Y parameter, I1 is equals to Y11 V1 plus Y12 V2. This is for Y parameter equation. So you need to form in this way. So what you will get? V1 minus H12 V2 is equals to H11 I1 is equals to H11 I1, you are getting V1 minus H12 into V2. So what is the result you are getting? I1 is equals to V1 upon H11 minus H12 by H11 into V2. So what is the, now compare this from this. So you are getting Y11 value is 1 upon H11 and Y12 value is minus H12 divided by H11, right? See, now I will tell you the beauty of this trick. the question, in the questions we took a lots of time, or lots of hour we had consumed for solving a questions. Okay, now if you know the trick, if you will find the single transmission network, you will get all the parameter very easily, very easily. So what you are getting, the h parameter, sorry, h parameter is h11, h12, h21, h22. And in terms of, if you want to convert this h parameter in terms of y parameter, what will the result? Y11 is equals to 1 by h11, y12 is equals to minus h12 upon h11, and y21, and anyone tell me what is the value of y21? h21 by h11, h21 by h11, and y22 is determinant of h by h, determinant of h by h11. So this can be converted like this. Okay, so this is your y parameter, means 1 by h11 is representing your y11 value, minus h12 by h11 is representing your y12 value, and this is representing y21 value, and this is representing y22 value. Now same thing, if you have a means for reciprocity in a y network, what we say, y11, y12, y21, y22. For reciprocity, this is the property of reciprocity, and this is for the symmetricity, means y12 is equals to y21, then the network is reciprocal, and if y11 is equals to y22, then the network is symmetricity, right? Then the network is symmetricity. Get the result for h parameter. For h parameter, what could be the property for reciprocity and symmetricity? Substitute it, 1 upon h11, y11 is equals to 1 upon h11, and y22 is equals to determinant of h divided by h11. So determinant of h is equals to 1, that means it is reciprocity. It's a reciprocity or symmetricity? It's symmetricity, na? We assume
Yes, sir. Symmetricity.
symmetricity. For reciprocity, you have to check this, na? This particular.
I made a mistake.
Yeah, okay.
Minus.
Yeah. So y12 is equals to y21. For this is for reciprocity. And what is the value of y12? Minus h12 divided by h11. And what is the value of y21? y21 is h21 divided by h11. h21 divided by h11. So this is getting cancelled out. If minus h12 is coming as a h21, that means it is reciprocal. Okay. So what we had studied, we already know the conversion of z to y is just an inverse. We already know the conversion from h to g. So means z is nothing but y inverse, g is nothing but h inverse, and we had studied the conversion of z or t to z, and also we had studied the conversion of h between h and y. So we are having all the possible combinations. Prasanna, your doubt is clear why we have not taken? So this is the things we know, because we know the conversion of a z to y, we know the conversion of a h to z. Now we understood the conversion of z to t, and we understood the conversion of h to y. Okay. So write the short notes, means make one table. Wait, just a minute. So write the conditions: symmetry, this side, and this side write reciprocity. Okay. For symmetricity, z11 is equals to Z22. It is equal. Z11 is equals to Z22 and Y11 is equals to Y22. For reciprocity, Z12 is equals to Z21 and Y12 is equals to Y21. Okay. Second one, for symmetricity, determinant of H is equals to 1, determinant of G is equals to 1. Okay. Here second one, H12 is equals to minus H21. Same thing will be for G because both are inverse. G12 is equals to minus G21. Okay. Third one, for reciprocity, A is equals to D. Okay. And for symmetricity, AD minus BC is equals to 1. That is your determinant. Determinant of T network is equals to 1. So this is a very important conclusion. Very important. Till now, everyone, it's clear? Or still, if you are facing any doubt, you can ask.
Clear, sir.
Okay. So, can we start the next topic tomorrow, or we can continue for a half an hour? Means the next topic is a different. That's why I'm saying interconnection between two port network. Okay, write down the heading. Just write down the heading in your notebook. We will start it tomorrow. I'm giving you some brief idea. So, interconnection between two port network. Okay, so these things we will start from tomorrow. In this we have to see now series interconnection. If two port network like this, means suppose you have a network, this is connected serially. If two serially interconnection network is there, if it is connected parallelly, like this, then what will be the net equivalent? Net equivalent, your Z parameter, your T parameter, or your Y parameter. These things we have to see. And after completing these cascade interconnections and all, we'll see some numericals. And after that we have what topics we are going to start after this. Let me tell you, just wait. So from tomorrow onwards, means like means after tomorrow we will we'll be in the next topic, like sinusoidal waves. Okay, sinusoidal, we'll start the chapter 3 from Monday. Okay, so tomorrow we'll complete all the two port networks problems and all. Everything will be completed tomorrow in a two port, and from Monday onwards we'll enter into the sinusoidal parts. Okay, Prasanna, Anish. So means have you understood, or means any suggestion you want to give me? If you are not getting the things, means the speed and all, any suggestion is, Anish, any suggestion, or the speed is okay for you guys? Prasanna, it's okay, or I have
Yeah,
to?
it's okay, nothing. It's perfect.
Perfect. Okay. Okay, guys, we'll meet tomorrow then at 9 p.m. Okay, good night. So
Bye, bye.
I have recorded the lectures.